Hi everyone, welcome back to Chemical Engineering Statistics. In this section, I will talk about the concept of regression. Engineers frequently use models in problem formulation and solutions. The models is used to understand a system characteristics and behavior. Only by then we can analyze and control the system. In general, models can be divided into mechanistic model and empirical model. Mechanistic models are those based on our physical, chemical, or engineering science knowledge of a phenomenon. For example, we know Ohm's law, the gas law, and Kirchhoff's law. However, there are many situations in which two or more variables of interest are related, and the mechanistic model relating these variables is unknown. In these cases, it is necessary to build a model relating the variables based on the observed data. This type of model is called empirical model. In statistics, we mainly use uh, the statistics to formulate empirical model. For example, please look at the figure on the right. In this figure, Y is the salt concentration found in surface stream in a particular watershed, and X is the percentage of the watershed area consisting of paved roads. There is no obvious physical mechanism that relates the salt concentration to the roadway area. However, the scatter diagram indicates that some relationship, possibly linear, does exist. In this lecture, we will only learn about simple linear regression. On the left, you can see the general formula for simple linear regression. In the simple linear regression model, we have dependent variables, or often called as response, and we also have independent variables, or often called as regressor variable. The independent variables mentioned as x, and the dependent variables or response mentioned as y. Epsilon is the random error term, while parameters beta 0 and beta 1 are called regression coefficient. The random error, or epsilon, express the difference of observed and estimated response, as we can see on the figure on the right. In general, the statistical data processing in regression is aimed to find the value of beta 0 and beta 1 parameters. To find those values, we can use the least square method. Using the least square method, we find beta 0 and beta 1 value, which creates the minimum sum of difference of square, sigma y minus y with hat square. If the regression equation predicts y value which measurement hasn't occurred, then y with hat is called the predicted value. If the regression equation is compared to actual y value of measurement, then the y with hat is called the fitted value. The mathematical procedure to find the beta 1 and beta 0 involves the partial derivative summation for parameters beta 1 and beta 0, as we can see at this slide. With a bit of simplification, we can obtain the linear equation system which are called as the least square normal equation. The solution to the normal equation results is the best estimator for regression parameters beta 1 and beta 0. The general equation to find the beta 1 and beta 0 value can be seen in this slide. That's all for today. See you in the next video.